Okay, so we're going to go through some Bohr diagram practice for Arduino today. We've already talked about Bohr diagrams. Some background information: Niels Bohr worked briefly in the lab of J.J. Thomson. Recall J.J. Thomson discovered cathode ray tubes. Well, he used the cathode ray tube to discover electrons, and he found out electrons were negative because when they passed through a positive negative plate, they were attracted to the positive plate. Then he went to Rutherford's lab. Rutherford, remember, did the gold foil experiment. He deflected alpha particles. He projected alpha particles at a piece of gold foil. He found out most went through, a few deflected back. This led him to conclude that the atom is mostly empty space and the nucleus has a small positive dense center because a couple were deflected back. So he knew the nucleus was positive. So then he went to Manchester to study radioactivity. And he arrived just after Rutherford completed his proposal of a compact nuclear core of atoms, meaning that the nucleus was positive. And in 1913, Bohr put his planetary electron model, consistent with Rutherford's nuclear model, on the table. And just the way that the planets orbit the sun, he said that electrons maintain stable orbits outside the nucleus. And he said electrons with more energy are further from the nucleus, because if you go from a low level to a high level, you have to absorb energy to do that. So if you're going further from the nucleus, you have more energy. He also said that 2 electrons can orbit the nucleus in the first energy level, 8 electrons can orbit in the second energy level, 18 in the third, and 32 in the fourth level. And we've already talked about this. I gave you notes on this. So, remember that we did talk about that. All right. So this is the answer to the first question down here. It says, I'm just going ahead, how many electrons can fill each of the 4 levels? So that's what you should be writing there. He also said that electrons can transition between their stable orbits by gaining or losing energy. So we know when an electron goes from a low level to a high level, it absorbs energy to do so. And, how do we excite electrons? Well, we can excite them like the easiest way, and the way that we're going to do it in the lab, is using a flame. We can put metals in flame and it excites the electrons, they absorb energy, and they move to a higher level. But eventually they go back down to the stable level. And when they do so, they release visible light. And they do this in the form of a wavelength. And that wavelength has a specific frequency and or energy. So we also said that each element has its own distinct emission spectrum, right? Which is the wavelength of colors that we're talking about. And this is very much similar to the way people have their own unique fingerprints. So when you draw a Bohr diagram, over here on the right, you draw the nucleus and then you draw the shells and you put your electrons in it. I'm actually only going to draw one for the actual first, the first full one, and then I'm going to show you a condensed way. But on the test, if you have to draw a Bohr diagram, you're going to have to do it like I'm doing this first one. So you should have your periodic table out, because you're going to need to reference that. So sodium is atomic number 11. So that means that it's got 11 protons. And the mass number here, 22 minus 11 is 11. So it has 11 neutrons. So here's our nucleus. And we know that it also has 11 electrons. So in my first shell, which I'm drawing now, I'm going to put 2 electrons. And it doesn't matter where I put them. And then in my second shell, I'm going to put 8 electrons, because the second shell can hold 8. The first shell can only hold 2. So 8 and 2 is 10. So that means that I have 1 left. So in my third shell, And this is why I don't like drawing Bohr diagrams, because they take a lot of space. I'll put 1 electron. So that's a Bohr diagram, and that's what you would have to do. All right, in the next one, I'm going to do magnesium. Magnesium is element number 12. So I'm going to do it a little bit differently. I got 12 protons. 24 minus 12 is 12 neutrons. So I'm not going to draw full shells. So I've got 2 electrons here. And then in my second shell, I've got 8. And then in my third shell, 8 and 2 is 10. I have 2. Okay, so that's another way that you can do it. And now you can still draw dots if you want, but I'm going to put numbers. But you have to realize that you actually have to know how to do it completely like I did in the first one. Chlorine is element number 17. So I've got 17 protons. 35 minus 17 is 18. I have 18 neutrons. So I actually have 17 electrons. So in my first shell, whoa, let me erase that. I don't know what just happened. Okay. In my first shell, I have 2. In my second shell, I have 8. So that's 10. In my third shell, I've got 7. So I'm just putting the numbers now. Argon. Argon is element 18. So I've got 18 protons. 38 minus 18 is 20. So I have 20 neutrons. I also have 18 electrons. So how many in the first shell? Good, 2. How many in the second? 8. 8 and 2 is 10. So how many in the third? 8. 18. Perfect. Going to potassium. Potassium is number 19. So I've got 19 protons. 39 minus 19 is 20 neutrons. That's my nucleus. I also have 20 electrons. So 2 in the first, 8 in the second, 8 and 2 is 10. That means 9 in the third. All right, calcium is element number 20. Element number 20. So I've got 20 protons. 40 minus 20, I've got 20 neutrons. These last 3 have the same number of neutrons. All right, in my first shell, I've got 2. Second shell, I have 8. 8 and 10. 8 and 2 is 10. So that means I've got 10 left. Okay, 20 electrons. Bromine. Bromine is element number 35. So I have 35 protons. I have 80 minus 35 is 45, 45 neutrons. So that's my nucleus. So I've got 2 in the first, 8 in the second. So that's 10. 35 minus 10 is 25. So I cannot put 25 electrons in this third shell, because if you go up here, I can only put 18 in the third. So I'm going to put 18 in my third, right? So 25 minus 18 is 7. So I have 7 left for the fourth shell. So all I did was subtract. And my last one is krypton. And krypton is element number 36. So I have 36 protons. And 84 minus 36 is 48 neutrons. I'm doing some review, as you can see, calculating my number of neutrons. And I have 36 electrons. So I've got 2, 8, whoops, I did 18. I was getting carried away. Let me fix that. All right, so we have 2, 8, then 18. So 2, 8, 18. So I'm up to 28. 36 minus 28 is 8. So I've got 8 in my last shell. Whoa. There we go. 8 in my last shell. So if you have to draw a Bohr diagram, you need to make sure that you don't take shortcuts if it's on the regions, and you have to do it like this first one here. Okay, I'm going to put a star there because that's what you have to do. These are like other shortcuts of Bohr diagrams. All right, moving on. Valence electrons are in the outermost shell. They are the furthest from the nucleus, escaping the protons pulling on them. Therefore, they have the most energy. So they have the most energy. Why is this not writing? Here we go. Whoa, what just happened? That was really weird. All right, I'll just do this. Most energy. I cannot write. Oh man, this is bad. Can you just type in most energy on your paper, please? Out of all the electrons, do any of the elements above have the same number of outermost electrons? So that, I don't have my drawings anymore. You're going to have to go back and see if any of them have the outermost electrons. So there are any that have the same number in that last shell. The electron configuration refers to the number of electrons in each energy level, starting with the nucleus out to the outer electrons. For example, lithium's electron configuration is 2, 1. What's the electron configuration for sodium? So if you go back to our sodium diagram, it was 2, 8, 1, right? And for potassium, it would have been 2, 8, let me see. I got to figure that out. 19 minus 10. 2, 8, 9. It would have been 2, 8, 9 for potassium. And are there any patterns that emerge that help the table be classified as periodic? So what we are going to see is, I might be able to type this one because I have a bigger space. Elements in the same period have the same number of shells. So we can put orbitals. And the other thing is, and elements in the same group will have the same number of valence electrons. And this is really important that you know that. So elements in the same period have the same number of shells or orbitals.